In unit number 4, we're going to look at some applications of derivatives. And in section 4.1, we're going to talk about the extreme values of a function. We're going to come up with a few definitions. We're going to start with relative extrema. And extrema is plural for maximums and minimums. We've talked about maximums and minimums, especially when we dealt with quadratics in previous math classes. So a function f of x is said to have a local or relative maximum. So the word local and relative mean the same thing. Value at x equals c if there exists an open interval containing c for which f of x is defined, and the function f of x is less than or equal to f of c for all values of x in the interval. So if you look at the diagram, here's a relative maximum right here, and we have another relative maximum right here. And if we were to look at the derivative at those points, the derivative would either be 0 there because it's horizontal, or this tangent line would be undefined because it happens at a cusp. So relative maximums can occur where the derivative is 0 or where the derivative does not exist. Similarly, a local or relative minimum is the lowest point on the graph, and it too can occur where the derivative is 0 or where the derivative doesn't exist. Okay, critical numbers. Critical numbers are numbers where the derivative equals 0 or where the derivative does not exist. So we said earlier that relative max and mins can only happen where the derivative is 0 or the derivative doesn't exist. So that means that relative max and mins must happen at critical numbers. All right, so let's take a look at some, first of all, how to find critical numbers. So the first thing we have to do is we need to take the derivative. So the derivative of this function is going to be 4 minus, that's going to be 4x to the negative 1/3. So again, if I was to simplify this, this would be 4 minus 4 over x to the 1/3. And if we wanted to combine these, we'd have to get a common denominator. So I'd have to multiply this side by x to the 1/3 over x to the 1/3. So this is going to equal 4x to the 1/3 minus 4 over x to the 1/3. So now I have my derivative as a fraction. So to figure out what makes the derivative equal 0, I just set the numerator of my fraction to 0, and I solve for x. So I can add the 4 to the other side. I can divide both sides by 4. And if I cube both sides, I'm going to get x is equal to 1. So there's my first critical number. And to figure out what makes the derivative undefined is what makes the denominator 0. So if I look at x to the 1/3 and set that equal to 0, that is only going to happen when x is 0. So those are going to be my two critical numbers. And that will be the only two places where I could have a relative max or a relative min. Okay? Now, one thing you must keep in mind is that every critical number is not necessarily a max or a min, but every relative max has to occur at a critical number. So let's just quickly look at the equation here, the Desmos equation. Let's see if we can graph this one. So we had the equation y, something's not working out there. We had the equation y equals, and let's just go back to what we had here. It was 4x minus 6x to the 2/3, so 4x minus 6x raised to the 2/3. And you can see here on our graph that I do have a place where it could be, I have a maximum at 0 and I do have a minimum at 1, and those are the only two critical numbers that I had when I did my mathematics. So again, they didn't ask us to find the max and mins yet, but again, we're just proving that max and mins can only happen if they do happen at the critical numbers. Okay, let's try the next one. And notice that we do have a restriction that x cannot be 3. Okay, so 3 is not defined. So first of all, I have to take the derivative using the quotient rule. So it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So therefore, if I simplify the top, I get 2x minus 6 minus 2x over x minus 3 squared. And this ends up being negative 6 over x minus 3 squared. So if I want to figure out a critical number, what makes the derivative 0, I would set the numerator to 0, and negative 6 equals 0 has no meaning, so there are no values that make the derivative 0. And if I want to figure out what makes the derivative undefined, it's going to be when the denominator, x minus 3 squared equals 0. And if we work that out, we're going to find out that when x is 3, that would be the number that makes the denominator undefined. So 3 could be a possible critical number. Now, if we tried to say that it's a max or min value, it can't be a max or min value because 3 is not even defined in the actual function. Okay, absolute extrema. Okay, absolute extrema is the absolute highest value on a graph, and absolute or global min is the absolute lowest value on a graph. Okay, so if we take a look at the graph here, okay, we would notice that I do have a closed interval. So this interval is going from 1 to 5. And on this closed interval, I have a highest value right here, and I have a lowest value right here. So the absolute max value would be the y-coordinate when x is 5, and the absolute max value would be 4. And the location of that would be at x equals 5. The absolute min value is the lowest value on my graph, and that would be negative 1. And it occurs when x is equal to 4. So you have to read these questions carefully. If they ask you for the location of the absolute max or min, then you're looking for the x values. If they're asking you for the absolute max or min values, then you are looking for the y values of those points. Okay? So the extreme value theorem is a value one that says if a function is continuous and closed on an interval a to b, there's guaranteed to be both a highest point, a global max, and a global min. And those maximums and minimums will occur either at the endpoints of my closed interval or at my critical numbers. Those are the only options. So you're asked now to find the absolute max and the absolute min of the function x squared minus 4x minus 1 over the interval 1 to 4. So the first thing I'm going to do is I'm going to find the derivative, and my derivative is 2x minus 4. Then I need to find the critical numbers. So first of all, what makes the derivative equal to 0? So 2x minus 4 equals 0, 2x equals 4, and x is 2. And again, this critical number fits in my interval, so it's good. There's nothing that makes the derivative undefined because my derivative is a polynomial. So therefore, my absolute max or min is either going to occur at 2, at 1, or 4. So what I need to do now is I need to evaluate the function at 1. I need to evaluate the function at 2. And I need to evaluate the function at 4. If I plug 1 into the original function, I'm going to get a value of negative 4. If I plug 2 into the original function, I'm going to get 2 squared is 4. This is going to end up being minus 5. And if I plug 4 into the function, I get minus 1. So therefore, my highest value here is negative 1. So this would be my absolute max. And my lowest value is negative 5. And that would be my absolute min. So again, to find absolute max and mins over a closed interval, we take the derivative, find the critical numbers, and then we evaluate the function at the critical numbers and at the endpoints. The highest value is the absolute max. Lowest value is the absolute min. Okay, let's try this one here. Again, note I do have a restriction that x cannot be 1. Okay, so if I take the derivative, again, it's going to be the quotient rule. So it's going to be x minus 1. When I take the derivative of the top, it's going to be the chain rule minus the numerator times the derivative of the denominator, and this is all over the denominator squared. So now I could factor in x plus 1 out of the numerator. I'm going to be left with 2 times x minus 1 minus x plus 1 all over x minus 1 squared. This is going to be x plus 1 times, if I distribute here, I get 2x minus 2 minus x minus 1 all over x minus 1 squared. So this is going to be x plus 1. This factor here is going to be x minus 3. And this is all over x minus 1 all squared. Therefore, I have to figure out what makes my derivative equal 0. And to figure out what makes the derivative 0, I set the numerator to 0. So therefore, I get when x is negative 1 or when x is 3. And to figure out what makes the derivative undefined, that's going to be what makes the denominator 0. And that's going to be when x equals 1. Now, if I look at my interval from 2 to 4, the only critical number I have to worry about is going to be x equals 3. So now I have to go back and evaluate my function at 2, at 3, and at 4. And again, why am I using those values? Those are my endpoints, and that's the only critical number that fits in my interval. So I go back and I plug, first of all, a 2 in here. Well, 2 plus 1 is 3 squared is 9, and 2 minus 1 is 1, so this is going to end up being 9. If I plug a 3 in here, 3 plus 1 is 4 squared is 16. 3 minus 1 is 2, and 16 over 2 is going to be 8. And if I plug a 4 in here, 4 plus 1 is 5 squared is 25. 4 minus 1 is 3, so this ends up being 25 over 3. So therefore, my absolute maximum is going to be 9. And my absolute minimum is going to be 8 because 8 is less than 25 over 3, which is 8 1/3. Okay, this is an actual multiple choice question from an AP exam, and it says let g of x be the function given by g of x is x squared e to the kx, where kx is a constant. For what value of k does g have a critical point at x equals 2/3? So as soon as you see critical points, we're thinking first derivative. So the first thing I have to do is take the first derivative, which is going to be the product rule. So it's going to be the first function times the derivative of the second, which is an exponential, which is itself, times the derivative of the exponent, plus the second function, which is e to the kx, times the derivative of the first, which is 2x. So if I clean this up a little bit, it's going to be k e to the kx x squared plus 2x e to the kx. And there's my derivative. Now, let's see what else it tells us in the problem. It says, for what values of g does g have a critical point at 2/3? Well, if it has a critical point, that means the derivative is 0 when x is 2/3. So I can put 0 in for the derivative, and I can put 2/3 in for x. So it's going to be e to the k times 2/3 times 2/3 squared plus 2 times 2/3 e to the 2/3 times k. So now I can do some simplifying here. First of all, this is going to be 4 over 9, because 2/3 squared is 4 over 9. So this is going to be 4 over 9 times k times e to the 2/3 k, plus this is going to be 4 over 3 e to the 2/3 k. It still equals 0, so now I can factor out an e to the 2/3 k. I'm going to be left with 4 over 9k plus 4/3. And if I'm multiplying two things and getting 0, either the first thing is 0, so either e to the 2/3 k is equal to 0, or 4/9 k plus 4/3 is equal to 0. Well, remember, e, an exponential, its graph is going to be like this or like this. It never crosses the x-axis, so there's no solutions to this. So solving this equation for k, I'm going to subtract the 4/3 to the other side. And then I'm going to times both sides by 9 over 4. So therefore, the 4's cancel, 9 divided by 3 times negative. K has to have a value of negative 3, so my answer is going to be A. So again, there's quite a bit of knowledge they're testing in that question. They're first of all testing whether you know how to take the derivative using the product rule. Okay, they're trying to figure out if you know that a critical number makes the derivative 0 at a specific x coordinate, and then you have to know that e to the 2/3 k can never equal 0, and then we're allowed to solve for k in that binomial there. Okay, if we take a look at the following sketch, we're asked to indicate whether the values of a through n are relative max or mins, global max or mins, both or neither. Okay, so let's take a look and make this a little bit bigger. First of all, we know that my absolute max occurs, I'm going to put those in blue, the absolute max occurs at k, because that's the highest point on my graph. The absolute min is the lowest point, which is n, so that's an absolute min. And this one up here was an, whoops, that was blue, sorry. This is an absolute max. Now, any other peaks that are going up or any other hills that are up would be relative max. So this would be a relative max. This would be a relative max. And relative max and mins can only happen at the interior of the graph. Now, some books, even though this is the absolute max and it's in the interior, they might even say that that is a relative max in that area there as well. Okay, as far as relative mins, I have a relative min right here. And I have, you could consider these three here also relative mins. Okay, and that would be all there would be for relative max and min. So again, to stress, absolute max and mins can happen either at the interior points or at the end points. Relative max and mins can only happen at the interior of my graph. Okay, so there is your assignment from section 4.1 on extreme values. So give those a try, and if you have any questions, you can ask me. Again, the bottom text is your AP text, the top obviously is your Calc 30.